Good afternoon, ladies and gentlemen, and welcome to our presentation about our new sensor, the ShieldScan. Today, me and my colleague, Nikolai Kemner from the technical support, will explain you the technology behind it. My name is Armin Behzadi, and I'm working as a key account manager for SensorTech, and I'm responsible for the areas Germany, Austria, and Switzerland.
And my name is Nikolai Kemner. I'm working in the technical department at SensorTech, and we do support for the products from SensorTech and Pepperl+Fuchs, do customer advisement, and also a topic of my work is the services, or sometimes even out of the office.
And before we start, we will show you an introductory video, and after that we will start with the topics. So, as you've seen in the video, we are talking about our new sensor, ShieldScan. It's the newest product of the Pepperl+Fuchs product family, and it is used for protecting swing doors. I can show you here the cover, how it looks like. It's very compact, and what is here really important to say is the low height, as you can see. And you can use it perfectly for doors with a small or thin frame, like it is usually for glass doors. And so the sensor will not touch the door. So you can put it perfectly over the frame, and this is one advantage of this product. Now something about the product description. The ShieldScan fulfills all the requirements of the EN60005. The EN60005 describes how a swing door should be. Before getting to the market, there are some requirements to fulfill, and all these requirements are fulfilled by our sensor. And now the first unique selling point of this product, it is the first door protection sensor with a static time of flight technology. Static time of flight technology. We are not working with moving parts, and we are working with a scanner principle. But my colleague Nikolai Kemner will tell you more in detail about it. And then the optimized beam geometry ensures that all parts of the door are perfectly protected. Also, the hinge edge, where you can pinch your fingers, this area is also fully protected. And as I told you, the main edge, the hinge edge, and also the solid state scanner. We have also one more unique selling point. It's the virtual wall function. It's like the area behind the completely open door will be hidden. But about this part, my colleague Nikolai Kemner will tell you more in detail about it. And also, our product is, it fulfills the requirements of the protection class IP65, and there are, till today, there are no sensors that fulfills this protection class. Also one unique selling point. Now, we have the technical part, and my colleague Nikolai will tell you more about it.
Thanks a lot, Armin, for your introducing words and telling us the main features of our new product, the ShieldScan. Now we will take a look together with me more in detail about the technical features and how we have mentioned, how we have realized to get these features in this product in technical details. First, let us start with a look at a typical application for this sensor. It is mounted on the swinging doors, as we have heard before. We have here an application which shows us two door leaves, and we can take a look at the shown beam path, the beam geometry of the sensor. We have 20 single channels, 20 single light beams which are produced by the sensor, and they are covering and laid all over the door leaf. So all of this area of the door is covered and secured by the sensor. The door leaf and the edges also. The sensor is mounted, as we can see in the picture, on the top side of the door, backwards mounted close to the secondary hinge edge, and it's mounted on both door leaves. So we use two sensor modules. In this picture we see the door from the side, from the hinge side. On the opposite side, which is not visible in this picture, on the opposite hinge side there is a very similar picture. The sensors are mounted also there on top side and backwards of the door leaf. Two modules are mounted, so we use two modules, one pair for each door leaf to get a full protection of this application. So we have here two door leaves in this picture. Therefore we need two sensor pairs, two modules on each door leaf. And now we take a closer look to the single light beams and how they are built on this sensor. At the light source we use the infrared LEDs, and I will now go to a part and compare this with another typical technology is used in this kind of sensors. It's the laser technology. So we will compare laser LEDs with infrared LEDs. Therefore, we have the topic of the temperatures of this operating temperatures where we can use this technology. One part is that the laser LED has a lower acceptable temperature when compared with the infrared LEDs. So up to 50 degrees, this is not a problem for both technologies. When getting to higher temperatures, the laser technologies will have become lower lifetime of this technology, and there are also some influence when regarding the MTBF values. So 50 degrees seems a very high temperature, but we can imagine when the sensor is mounted on a door at the outer side, at the facade of a building, and maybe the frames of the doors are black, and in the summer when the sun is shining about mid of the day, it gets really higher temperatures, and then when it goes up about 50 degrees, this is right possible, and the sensor with the LED technologies will get a shorter lifetime when compared with the infrared technologies. Another big point we have to regard is the dimensions of the diameters of the LED, of the light spots. So the spots of the infrared LEDs are bigger and the opening angles are a little bit higher when regarding it or comparing it with the laser diodes. So we have not so hard focused laser light, and when we regard what happens when the door starts to open and in front of the door is is an obstacle, a person for example, the sensor will detect this, the light beams will be interrupted, and the sensor will send a signal to the door driver to stop. So because of the mass and the dynamics of this door, the door will not come immediately to the stop. It will swing a little bit more to the opening position and stops and swing small back. And so it starts to swing a little bit in this position. So when we have a sensor with a very small and thin focused light beam, it can happen that this object in front of the door will get detected, and the sensor will get on this object and swing back and lose the detection, and then comes back and detects again. So we have a toggling situation, and in extreme cases the sensor will send to the door driver the signal to the door drive unit. The area in front of the door is free, and the door will start to continue opening and starts the movement again. So we can get a swinging situation of the door, and this is not willing by operators. So what we can provide with our sensor, we use the infrared light technology, and we have this smaller lights, this bigger light spots in the diameter compared to the laser LED, and so we can detect the object in front of the door continuously during the stop moving of the door, and until the door has completely stopped, we have a continuous and secured detection of the object, and no swinging movements of the door will occur. Regarding this part of the door leaf, we will now come to the hinge edge and take a look at the light spots, how they are placed in this area of the door. Here we have the big advantage that we can use a solid state scanner principle, and this allows us to position the single light beams, the single light channels of the sensor regarding and in accordance to the application requirements. We can see this here very well in this picture. And first of all, we want now compare our system from the ShieldScan with with this new technology of solid state. When we compare this now with another sensor principle, this is a multi-beam sensor. So we see here one product of this type. It is from our house. Here we can see the green cover. It's a Pepperl+Fuchs product from the R2300 series. So this sensor creates with a light LED and a small rotating wheel with several mirrors placed on it. We create with this sensor several detection areas. The mirrors are in a slight multiple angles placed on this wheel, and with this feature we can create several detection areas, one behind another. So this sensor creates 4 several detection areas, and they are placed one behind the other, so we can now create a detection in the 3rd dimension in the depth of the detection fields. And so this is another technology we use this here to get a 3-dimension detection. But we have to regard this sensor only can create plane and flat areas placed one behind the other, and the gap between these several detection areas is not completely protected. So we have plane and flat areas, and these detection areas hit the floor, which is also plain. We keep this in mind and look now at this picture, this detail at the door. On the top right, we see what it means when a sensor, a multi-ray sensor, we have to say for this product, it's not really 3D sensor, which is often used. It's a multi-ray, multi-layer sensor. This multi-layer sensor creates on the floor a straight and plain line, which is just parallel to the door and the wall, and this line is just straight. We cannot change this. When comparing with our system, the solid state principle, we can do individual geometry of the light beams by placing the single LEDs according to our requirements on the PCB boards of the sensor. So we can handle that at this dangerous zone of the hinge edge, that we can bend this single light beams a little bit. They are curved and swiveled out around this area, and so we have a better protection. Can see here in this curved, slightly green shown path when comparing with the multi-ray scanner with this just straight detection area. So this part is very good protected and is protected, yes, for round side grabbing. So if children, maybe we are in an application where many children are there, kindergartens, for example, and it's possible that a small kid grabs, is placed here behind the door starts to close, and it grabs this kid with his hand right along the wall towards this hinge edge, and the danger will be there that he get pinched with the fingers when using a sensor with a straight detection field. So we have here this curved, and it's just bent around this area of the hinge edge and give a very good protection. They can detect the hand, the whole hand, by swiveling out the single light beams. This allows us to get the detection far away from the dangerous zone, so we can detect early enough before the fingers can reach the edge and get pinched there. Regarding our hinge edge, we are now go over and take a look at the main edge of the door, and in this picture we can see how the single light beams are placed there. So they are bent a little bit forward, and they are lead right over this handlebar. We have here this vertical handlebar at the door, and the beams of the main edge, they are lead in front of this bar, and they look just in front, yes, of this bar. They are not detecting it, so we have no disturbing detections of this component, and we can also lead the beams right over directly to this hinge edge, to this main edge. To the main edge. We can detect the full width of the door until this edge where the danger zone is placed. Here a feature of we have already heard about, the solid state scanner is realized here, no moving parts, so we do not have any rotating components inside of the sensor. This means we have absolutely silent, soundless operation of the sensor. This is a big advantage when regarding applications where really silence is a big topic, for example, in hospital, operating rooms, or in concert halls, where the sensor, where you want to receive really silence or a special acoustic in event, and then this sensor will make no noises and disturbing sounds. This feature is integrated in the sensor silent operation for silent environments. From this part we come now over to a very new feature we have integrated in this sensor. It's the virtual wall function, and this allows to adjust our protection field according to the opening movement of the door. The virtual wall function, what is this meaning in detail? We can see here this virtual wall in the light blue pattern. It's shown. Classic sensors which are used earlier, they use the really existing wall behind the doors as a reference when they be teached in and when they are in operation mode. So they teaching and uses these walls as references, and if there are some objects placed, this can be this can cause problems when do the commissioning of the sensor. For example, fire extinguishers or radiators which are placed behind the door, they are detected during the teaching procedure, and this can cause problems, troubles, and we need an ideal plain and really flat wall to get a reliable operation of the sensor. So what we have now realized with this virtual wall, we have completely uncoupled from really existing walls. We use now a virtual, not really existing wall, and this is the reference for our sensor, which is which is learned by the sensor during the teaching and which is used during operation. In this picture, we can see how this wall, how this wall looks like, I want to say, and I can describe here very good for you how it is positioned. So during the teach-in procedure, the door makes completely movement, completely open, and completely closes again. During this door movement, the sensor has included a small positioning element. It's a gyroscope, and with this gyroscope, the sensor can detect at every moment of the door movement the angle and the positioning of the door leaf and of the sensor. So he can detect the opening angle, and with this component he can learn the maximum opening angle of the door, and during the teach-in procedure and the completely door cycle, he learns this angle, and when the door is closed again and the commissioning up is finished, the sensor stores this angle and places this virtual wall right behind the completely opening angle of the door. So all of this part of the open door, the sensor is placing this virtual wall, and how this virtual wall helps the sensor working, we will see in the next picture. On the next page there is an example for application. Here we can see this small the door, and behind the open door there is placed a plant pot, for example. In this picture we can also imagine this can be a louver when it's outside wall of the building, and we see here the glass front, so it's for protection of sunlight and keep the heat and the bright sunlight out of the building. There are louvers placed, at this part, and they can go down when the sun comes out, and when it hides back again, they will move upwards, or it's a small shop where maybe some special offers, some goods are placed outside of the shop behind the door in this area during the opening times. So all these parts causes changings in the place behind the open door, and in the classical sensors which are referring to this space, this can occur problems during operation, and it even can come to this effect that you have to reteach, do a new teaching of the sensor when this area and the objects there are changing. So with the feature of the virtual role function, we suppress completely this area behind the open door. We see in this right picture the position of the virtual wall, and the door starts to open. At this picture, first the angle is still very small, 27 degrees, so all light spots are still active and they are detecting the moving area in front of the opening door. So when the door starts open more to higher angles, the sensor will start to detect the virtual wall, and the single beams will successively reach the virtual wall in their placed order in the picture from the left to the right side, always from the hinge edge to the main edge. These beams will hit one after another this wall, and when they reach the virtual wall, there will be suppressed, there will be hidden, and they will not longer detect. So and the final result of this effect we see on the picture on the picture underneath the first, and here the door has now completely opening angle now 90 degrees. All of the single light beams have now reached the virtual wall, and they are now all hidden, they are now all suppressed, so they are not longer shown in this picture. They are still operating, they are still switched on, but the detection of them is not longer evaluated by the sensor. So if they hit or they detect some objects behind the virtual wall, they will not be evaluated and will not be detected. And so we have uncoupled this area, this complete zone behind the open door, and changings there will not have an influence on the sensor operation. From this part of the virtual role function, we now come to the next page, and here we see the options of the sensor regarding design. We have heard about a very small height, so the depth of the sensor housing is also a topic, but the really small height of the housing we can see in this application one more time, and this allows us to place it on the frame of glass door, and the pane of the glass door is not covered by the sensor, it's not extended on the glass, so it's totally placed in the area of the frame. And the option we can also provide is the different colors for our housing, so this makes a very smooth and smooth integration of the sensor in the door frame, and it's almost not visible when mounted there. In this picture we can see our another feature, the very high protection class, and we can now take a look how we have realized this. We have designed the housing in this way that splashing water by raindrops, for example, are lead from the housing on the sides to the sides and then downwards of the sensor, and they will drop off this sensor housing, and without come to the inner parts of the sensor. So it's secured from water. And forget this high protection glass, we also have placed a rubber sealing which is placed all around the sensor housing and keeps moisture which can come up in autumn, for example, in the air. They will kept out of the sensor and not reach the inner parts, the mechanical and electrical components there. Here in the picture, good to see these parts. In this place, there are allocated the objects. Here are the transmitters and receivers of the sensor placed, and in this section we have the control units of the sensor. The setting dial for adjust the angle and adjust the angle of the sensor to take care of the height of the door and adjust this value. We have here a small hole behind. Placed is a small multicolor LED, and this shows the actual status of the sensor during the commissioning up process. Beside of this, we have a small block with dip switches to choose the several operating modes according to the application requirements. And here at this part, the small red teach-in button to start the commissioning up procedure. On the left side in this picture, under the green cover, is placed the I/O module of the sensor, and there is also integrated the signal output type. We have heard now about the features of the sensor, the technical components, and how we use these control units also for commissioning up. The commissioning up process is very simple and quick to do. During this process, we start the teaching procedure, then the sensor will learn the floor and the reflective grade of this ground and will be taught in. And in another step, he will learn about this environment of the door by doing the completely drive cycle of the door. Completely open and close again. And we have to install, we have to do the settings on the sensor and then start the procedure of commissioning up. We adjust the setting dial and set the dip switches for setting the height of the door, the width of the door. It's very easy to teach in. We don't need another control or a remote controller, for example. It's just enough to do a gesture control by teach in with a simple hand movement vertical along the main edge. This is the way how we teach in the width of the door during the commissioning up of the sensor. Now we come over from the technical details back to the commercial and sales topics, and this is part again of my colleague Armin, and he will now come back and take over.
Thank you, Nikolai, for your perfect explanations. Now I will tell you something about the technical data. As you can see, the dimension, it's a very, very compact product, as I told you in the beginning. Also the mounting height allows you to use it for any kind of doors. And also the IP65, which was explained perfectly by Nikolai. And also very interesting, the ambient temperature, it's from -30 till 60 degrees. It's like for any kind of weather. And also the signal output, we have the SSD, solid state relay, the NPN and PNP, and the CAN. And yes. Now something about the portfolio and availability. If you want to buy ShieldScan, you have to answer 3 questions. The first question is which color of the sensor should I buy? We have it in white, gray, and black. The second thing is which part of the door should be protected, like the whole door or just one side. And the third question is which signal output should I take, like the NPN, SSD, or yeah, the same. So now I will tell you something about the application. You can see it here perfectly on this picture that all of the parts of the door are perfectly protected. Also the hinge edge, which is very important. And you can see it here at this example that the package in his hands is protected, and also himself, like here the interface also, like when this door opens and gets closed. So the interface and all of the parts are perfectly protected. Now the highlights of our ShieldScan, the optimized beam pattern, what I told you at the beginning, that ensures to secure the main edge, hinge edge, and all parts of the door. The solid state scanner with the time of flight technology, the less planning time also, and the seamless integration with low profile corner mount housing. So these are all the highlights which was explained by my colleague Nikolai Kemner. And now we will show you the package, like how it looks like, and all the parts inside. And yeah, Nikolai will explain it in detail.
Yes, now we can take a look at the final part of our presentation to a really existing sample of our sensor. We look inside, something falls out, right? And we can see the content of the original package starts with our just flown away manual. Here they are described all the topics for installation, mounting, and teach in the sensor to help you by installation and mounting of this product. Also included are some schemes for drilling the required holes to mount the sensor. We have here the 3 holes to drill and fix the sensor at the door leaf. 3 pieces are required. This scheme helps to place and find the right positions for drilling, and in this space we can put in the cables between which connects the 2 sensor modules between the hinge side and the opposite hinge side. For both modules we have this scheme there. Also, now we look at the electric components. Starts with the cable connecting the sensor with the control unit of the door drive. Here there is a small plug which you can put in the sensor and fix the cable for connecting right there. Also included this hose for protect the sensor against mechanical influences and keep this cable safe, and a small clamp to fix this cable with the hose together at the side of the door, and so it is placed and fixed on this area. Also included are all the screws we need for mounting the sensor. Here this is for fixing the cable outlets at the sensor, and the screws for mounting the sensor modules itself at the door leaves. And at final, a very small, tiny cable. This is the connection cable which is lead right through the door leaf. You have to drill one time straight through the door from the hinge side to the opposite hinge side and lead this cable through the door leaf. It has very small and filigrane plugs, so it's okay to use a drilling mounting hole with only 8 millimeters in diameter, and this is allowed even for doors used in fire protection requirements. And now, at last, we can take a look at our sensor modules. This is the secondary module, which here we can see the black cover version, black cover of the sensor, and here we can see in reality the really small depth of the housing and a really compact height too. Remaining one last piece. This is the primary module of the sensor. There is, it looks similar from the outside as the right seen before module, the secondary one, but inside of this sensor is integrated the I/O master module. So we can take a short look at this, and therefore I'm going to open the sensor. To open it, we need a small tool. A tiny screwdriver is necessary. This is important for technical regulations, for TÜV, for example. They recommend this because it's not allowed to open the sensor without tools, just the hand, so not authorized persons cannot open this sensor and do manipulations there. For opening, we can use the screwdriver and put it right over the. Here is the cable outlet, and above this hole there are two small openings. We take the outer side of these holes and pressing slightly with the screwdriver to the outside and upwards and get this wall of the small clamp on this side. Already happened, and now we can move the cover to the front side and upwards to open the sensor. Inside of the sensor we found the setting controls, the control parts for do the settings. Yes, here the setting dial, adjust the inclination angle of the sensor according to the height of the door. This is the small LED, multicolor LED showing the status, and here we see the dip switches to choose the several operating modes according to the application. And at this side, this is the teach-in button to start the commissioning procedure. Here we see on this part, between these two parts, a quick installation guide to help the mounting personnel for get a quick start and setting up of the sensor. And this is our I/O module. The primary module of the sensor contains it, and there is included the signal output stage. We can remove this part, therefore I have to turn the sensor horizontal and release this small two clamps. Then we can plug the sensor, this I/O module off the sensor. Sensor base put right here, and here we can see this I/O module. Green cover plastic from the front side, and on the back side the PCB board, and there are included the signal output. So this here is the plug for connecting the cable which leads over to the door controller. So the advantage of this principle of mounting is that we can use one basic module of sensors, and for getting the several signal output stages, we can just plug off and on another I/O module. We can just change this small module, put it out, and another one in, and so we can change the several signal outputs and create the several options of the sensors. And this is an advantage when mounting the sensor, because so it's very easy to change and quick, and it's also for topics of storage an advantage, because when we're using this type of mounting, we need very small storage space for store all different variants of this sensor. Sensor just has gone to the side. Thank you, Armin, for replacing it. We have now seen the features in our presentation, and I'm really glad that we can show you one of our very first samples of this sensor to give a practical, realistic picture of the product. And so from my part and Armin's, this is the main topics of our presentation. I say thank you very much for your attention and your time, and hope this helps you to understand the new ShieldScan sensor for door protection better now.
And also one point, if you need any samples, like for testing the sensor, just contact our sales team. And also if you have any questions, just contact our sales team, all our technical support. And also thank you from my side that you join us, and yeah, stay healthy.
Yeah, we'll be pleased to hear you and give questions to us if you have any, and then stay healthy, safe. Thanks for your time. Bye.